Doctor, you will talk about the final exam tomorrow, inshallah,
Final exam?
if
What
possible.
exam? You mean theory exam or lab exam?
Questions? No, the theory.
Huh? How the theory exam will be tomorrow?
He says, Doctor, may you talk about
No.
it?
I
Give us
mean,
some
how
information.
he has some informations, anything about it.
No, I don't get these type of messages, my dear. I hope you already received the exam schedule for this semester. Am I right? Still, you don't receive anything?
Yes. No, Doctor,
Doctor,
You
we
received
just
or not?
ask about the time.
uh, no,
Then what you are
the
talking
content
about?
of the content of the exam, how many
My dear,
questions,
I
yes, like
already
this.
told you the
I mean,
content of your exam is exactly comes from what we discussed from the class.
We
Clear?
know, Doctor, we asking about like the general, the concept or the general idea about the final exam. How will be? Like, for example, will be typing questions or like this. You get my idea? Like general
You
idea
mean,
about the exam.
my dear, I told you
yes.
already, your final exam question will be exactly similar like your midterm exam. Your theory question must be in MCQ type question, and your numerical type question, you
Mm.
have to write the answer. We provide some space, so you have to give the answer in that space. Exactly similar like your midterm exam. Clear?
Doctor, the numerical questions will be like the midterm. I mean, from
Yes.
the slides, nothing out of.
My dear, in midterm exam, we never ask any question outside the
Uh,
syllabus.
yes. Same the
Exactly
questions
similar
that
like
we discussed.
same.
Oh,
Yes. Study the slides completely because we prepared the slides based on the content, and we reduce the problems from chapter number 25 to 30. Am I right? Just to work out that
yes.
problems, and please go through whatever the things we discussed from the chapters slides. Clear? And there may be a chance for asking some theory question from the slide. So you should be very careful when you just go for solving the questions. You have to read. You have to see the video from top to bottom what we discussed from the class. Clear?
Doctor,
Yes, brother. Yes.
the theory question, it will be from chapter 21.
Theory question from chapter number 16 to 30. It will be there. From any chapters we may ask. I'm talking about the maximum question. The majority of the questions will cover from chapter 25 to 30, and from the previous chapters, so for sure, some question will be there. So for your entire chapter for your final exam, it started from 16th to 30th chapter. That means totally 15 chapters are covered there. So there may be some question from chapter number 16 also. There may be some question from 17 also. But the majority of the marks, because you are going to write the final theory exam for 30 marks. Out of the 30 marks, majority of the questions will cover from, because we already tested your knowledge up to quiz 2. Am I right? So we consider chapter number 24 for your final quiz 2. Am I right? So from chapter number 25 to 30, still we did not tested your knowledge. So most of the question out of these 30 marks, majority of the marks comes from chapter number 25 to 30. And from the previous chapters, there may be chance for asking some question, theory questions or numerical question. 1 mark question will be there. Clear? Clear?
Yes, Doctor, clear. And
Okay.
Doctor, the theory, it will be 6 marks.
I think so. 6 to 7 questions will be there.
Okay, thank you.
You didn't finish the.
I didn't. Could you please ask your question again, my dear? Excuse me. Abdurrahman, your voice I couldn't hear. Is my voice is audible, my dear? Is my voice audible?
Yes, doctor.
Yes,
Okay.
Doctor, wait.
Okay, please, you can ask your questions after the session, my dear. We no need to waste our time. Mr. Abdurrahman, you can ask your question after I complete the chapter. Okay? Clear? Okay. I hope you can see my screen now. Is it visible?
Yes, Doctor.
Okay. So these are all the questions we confirmed for chapter number 29. We already discussed in our group meeting with both male branch and female branch. And these are all the questions we considered for chapter number 29. And out of these 3 questions, we already completed chapter number 6, the question number 61 in the last class. So still we have 2 more questions, question number 10 and 23. And these questions are exactly comes from what we already discussed from the theory. So better we can recall, better we recall the formulas. What are the formulas? Whatever the formulas we discussed, we just recall the formulas by using the summary slides. We discussed the formula of the Biot-Savart, and then we studied what should be the force between parallel currents when you have 2 parallel wires. If that parallel wires carrying the current, what will be the rule? And the Ampere's law we already discussed. And then this is the formula for the magnetic field calculation for the long straight wire. So we took these 3 problems based on these things we already discussed from the theory class. So we just go for chapter number 10. Sorry, question number 10. This question looks like a little bit bigger because of the pictures as well as the information what we gave here. So please, my dear, read the information what is given in the questions very carefully, because these questions have 5 subdivisions. Sub questions are there. In a question, there are 5 sub questions are there. So if you know the answer for the first question, the rest of the question B, C, D, and E will be exactly in the similar way. But you must know what is given in the question. Once you understand what is given in the question, then calculating the information for that 5 sub questions will be very easy. And better you can just see the picture also. What is given in the picture, my dear? In figure, 5 parallel wires in an XY plane are separated by the distance. My dear, don't get confused about this, because here the axis is given in terms of Y and Z. But here they mention XY plane. So actually the picture is exactly in XY plane, but the picture is given from the aerial view. That means you have to see this picture from the top of the wire. So that means you have 3 axes, X axis, Y axis, Z axis, and the picture is given in the view of aerial view. That means you have to see the picture, see the wires from the top view. So when you see the top view, actually the wires are placed in XY plane. So that's what this picture looks like, because last time one student he asked, doctor, in the axis you mentioned Z axis and Y axis, but how they said the wires are in XY plane? Actually the picture is given in the aerial view. So when you just see these 5 wires, or what are the 5 wires here? You can see the number 1, 2, 3, 4, 5 are the wires you have to see from the top view. So when you just see the wire from the top view, you can see only the cross-sectional view of the wire. And these wires are kept in XY plane, because the Z axis there will be no wires, only you have the wires only in XY. So when you just see this picture in the 3-dimensional point of view, then you will understand, because we are just seeing the picture from the aerial view. That means we just see the picture from the top view. So then each wires are separate with a distance 8 centimeter. You have to see here, all these 5 wires are separate with a distance D. So that means the distance between wire 1 and 2 is D. Wire 2 and 3, the distance is D. And that means for each wire, the distance is given as 8 centimeter. That means better we can write what is given in the question. So the distance between the wires are given as 8 centimeter. And we have to convert in terms of meter, which is nothing but 8 multiplied by 10 to the power of -2 meter. And each wire have the same length, and which is given as 20 meter. That means the length of the wire is given as 20 meter, and each wire carrying the identical current. What is the meaning for identical current? From wire 1, wire 2, wire 3, wire 4, and wire 5, the same amount of current is flowing. That means all wires carry the same current, and the wire carrying current information is given. That means the current in the wire is exactly given as 3 amperes, and all these wires are coming out of the page. Why it is out of the page? Because of that rounded symbol. I told you already, whatever the things, if it is rounded, it is says the wire is coming out of the wire. If it is crossed, the wire is going into the wire. The same like magnetic field what we studied. That means all the wires are coming out of the page, and you have 5 wires, and each wires are separate with a distance 8 centimeter, and each wires carrying the same amount of current, which is nothing but 3 amperes, and the length of the all 5 wires are exactly 20 meters. So these are all the information given in the wire. And now each wire experiences the magnetic force due to the current in the other wires. We already studied. Do you remember this? Better we can just go back to this slide. So what we studied from this slide, my dear, you have 2 parallel wires, because here in the question also they said all the wires are parallel to each other. So when the current is in the wire, when the current is flowing through the parallel wires, what will happen? Each wire will have the magnetic field. That means this wire, for example, you can see this picture. This wire I am going to take A, and this wire I am going to take B. What will happen when the current is flowing through the wire? The magnetic field will be generated in the wire, and that magnetic field will affect the second wire. And this information we already studied in the last class. So that means the magnetic field of the wire will affect the second wire B. Likewise, the magnetic field of B wire will affect wire A. So that means you can see the picture. This wire magnetic field touch the A wire, and this wire magnetic field touch the B wire. That means the magnetic field from each wire will affect its neighboring wire. So that information is given here. So each wire experiences the magnetic force. Why? Because each wire is carrying the current. When each wire carrying the current, each wire will have the magnetic field, and that means this magnetic field. For example, let's we take the first wire. When the first wire, when you consider, what will happen? This magnetic field will affect the neighboring wires. And likewise, when you consider the second wire, the magnetic field for the second wire will affect the remaining 4 wires. If you consider the third wire, when third wire carries the current, the magnetic field generated by the third wire will affect the remaining 4 wires. So that informations are given here. So now what we are going to do, we are going to find the answer. Which answer? We are going to find the magnetic force. That means we are going to find the net magnetic force experienced by each wire. That means we have to find the answer in terms of vector notation. But first of all, we must know what should be the superposition principle. We already studied this principle in previous chapters. That means when you consider the force 1, that means this force will have the interaction with the second wire. This force has the interaction with the third wire magnetic field. That means each wire have the same current, and each wire will have the magnetic force. And each wire will have the magnetic field also. So now what I'm going to do, first I'm going to give the explanation for the first wire. So please, my dear, listen my informations what I'm going to give here. And we are going to apply the same principle, same information for the rest of the 4 questions. So if you want to find the answer in terms of vector notation, if you want to calculate the magnetic force, first of all, we must know what should be the magnetic force experienced by the wire. That means we are going to use this formula. We are going to use this formula. Because here all the wires, because we consider 2 wires, the 2 wires have parallel currents, and these 2 wires are exactly kept in the parallel to each other. That means these 2 wires are separated with the distance d, and these wires have the length l, and these wires have the same amount of current. So what we are going to do, I'm going to use this formula for calculating the answer for the first question. But we have to find the answer in terms of vector notation. So what I'm going to do, first I'm going to give the answer for the first question. What should be the magnetic force? Net magnetic force. That means what is the net magnetic force? The net magnetic force by wire 1. What is the net magnetic force by wire 1? That means the magnetic force in wire 1 will affect will affect the second wire, will affect the third wire, will affect the fourth wire, will affect the fifth wire because of the magnetic field. So how you can find the net answer? We have to write the force on wire will exactly equal to the force 1 on second wire plus the force 1 on third wire plus the force 1 on fourth wire plus the force 1 on fifth wire. We already studied this principle in the previous chapters. That means a current in a wire will affect the neighboring wire. So what we are going to do, we are going to apply this rule. Which rule? We are going to apply this rounded symbol, because we are going to apply this rule for this principle, for this equation. So I'm going to apply this rule one by one. I need the answer from your side. So let's we just write. I'm going to explain step by step for the first wire. In the similar way, you have to work out for the rest of the wire. Please, my dear, if you're sleeping, please listen, because this is one of the important topic in chapter number 29. So let's we apply the rule. What is the rule? The force, the magnetic force on the first wire, which is exactly equal to, I have to write what should be the magnetic force 1 on second wire. So we know the rule, mu naught, and this wire carrying the same current. Which wire? Because we consider only the first one and second one for this. That means current in first wire, current in second wire, and this wire has the length divided by 2 pi multiplied by the distance between the two wires. So in the similar way, I'm going to apply the same rule for F13. So how you can write? Mu naught, the current in first wire multiplied by current in third wire, and the length of the wire divided by 2 pi d. Likewise, I have to apply the same rule for 1 on 4. That means mu naught, current in first wire, current in fourth wire multiplied by length divided by 2 pi d. Likewise, for the fifth wire, 1 on fifth wire, mu naught, the current in first wire, the current in fifth wire, the length of the wire divided by 2 pi d. So what we did, we just apply the rule for every two wires. That means we have to consider the first wire as the common wire for the rest of the four wires. Clear, my dear? Understand? Is it clear?
Yes, doctor, clear.
Okay. Now we must know what is the distance. That is very, very important, because I just simply apply the rule. But what should be the distance? Because could you please tell me what is the distance between wire 1 and 2, my dear? What is the distance between wire 1 and 2?
8.
Just tell me. We substitute the value later.
D.
What is the distance between wire 1 and 2? D. Am I right?
1
Am I right or not? Okay. What is
Yes.
the distance between wire 1 and 3?
2D.
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 So we have to apply what? What we have to apply, my dear? What we have to do here? Better in this place,
it
I'm going to remove
2D.
this D. Very good. So I'm going to write 2D here. Why? Because the distance between wire 1 and 3 is 2D. Likewise, what is the distance between wire 1 and 4?
3D.
So in this place, I have to put 3D. What is the distance between wire 1 and 5?
4D.
That's it. Clear? Clear, my dear? Clear?
Yes, doctor, clear.
Yes,
Now,
doctor.
better if you want to solve very easily, better we can take the common term outside. What are the common terms we have? My dear, listen carefully. We have identical current. That means my I value I2, I1, I3, I1, I4, I1, I5, all are same. Am I right? Am I right or not? That means the identical current means
Yes,
what they
yes.
say, I1, which is equal to
Same
I2,
current.
which is equal to I3. Sorry, not equal. Okay. So that means I3, which is equal to I4, which is equal to I5. That means all currents are equal currents, identical current. What's the meaning for identical? Same amount of current is flowing through these 5 wires. So how I can write? I can modify this equation as mu naught I square L divided by 2 pi d plus mu naught I square L divided by 2 pi multiplied by 2d plus mu naught I square L divided by 2 pi multiplied by 3d plus mu naught I square L over 2 pi by multiplied by 4d. Because I don't want to skip any steps for the first part. In the rest of the 3:4 parts, I'm going to skip some step because we are going to use the same principle. Okay, now I'm going to take the common term outside. What are the common terms we have, my dear? My dear, I square is a common in all the term. Likewise, the length is also the common term in all the division, all the parts. And likewise, 2 pi d is the common. So I'm going to take the common term outside for finding the net magnetic force on wire 1. So that means F1, which is equal to, I'm going to take the common terms outside, mu naught I square L over 2 pi d I'm going to take. So what is coming inside, my dear? Here, this becomes 1 plus 1 over
2.
2 plus 1 over 3 plus 1 over 4. Am I right? Am I right?
Yes, doctor. Yes.
Okay.
Yes,
Now
right.
I'm going to substitute the value. So better I can rewrite this equation one more time. Mu naught I square L over 2 pi d. I can just write one more time. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And now I'm going to take the LCM for this bracket symbol. So what I can take, my dear? I have to take the common terms for this bracket. So how I can write? I can take 12 as the common term. Am I right? I can take 12 as the common term. So if you want to get 1, what you have to do, my dear? In the denominator we have 1. So you have to multiply both numerator and the denominator. So you will get a 12 in the top. Am I right? Am I right or not?
Yes.
Okay, if you want to get a 12 here, which number you have to multiply? 6. Am I right?
Yes.
So that means in the top I will get 6. And if you want to get a 12, what you have to multiply? 4. So in the numerator also I have to multiply by 4 plus 4. And if you want to get a 12, you have to multiply 3 here. So I have to multiply by 3 plus 3. So what's the total value, my dear? Mu naught I square L over 2 pi d. And here if you just
25.
add all these things, 12 plus 6, 18, 18 plus 4, 22, 22 plus 3, 25.
25.
So 25 divided by 12. Am I right? Am I right?
Yes.
Now substitute all the
Yes,
value.
right.
I told you the value of mu naught, because mu naught is the constant value. What's that value, my dear? 4 pi multiplied by 10 to the power of minus 7. So in place of mu naught, I'm going to write this constant term. So in your exam, we will give this value. In your exam, we will give this value. So don't worry about the constant term. So what I'm going to do, I'm going to substitute the value to 4 pi multiplied by 10 to the power of minus 7. And what's the current? We have the current as 3 amperes. That means here we have I square, so 3 square. And what's the length of the wire? The length of the wire is given as 20 meters. So I have to write 20 divided by 2 multiplied by pi multiplied by, what's the distance, my dear? The distance
8.
between the two wires is 8 centimeter. So 8 multiplied by 10 to the power of minus 2. And inside the bracket, we have 25 divided by 12. Could you please tell me the answer? Could you please tell me the answer, my dear?
$9.37.
9.37.
Yes. Or
Wait. I'll check the
you can
answer
round
later.
it.
Okay. Okay. What's the number? What's the number you got?
9.38
Okay.
multiply 10 minus 4.
10 power minus 4. My dear, we
Newton.
calculate the force. What's the unit for the force?
Newton.
Newton. And you have to give the answer in terms of vector notation. Just go back to the picture. All the 5 wires are exactly mentioned in y-axis.
Y.
Am I right? So what is the vector notation for the y-axis?
J.
J cap. That's it. Clear? Clear, my dear? Let's check our answer and then we will come back. Yeah, we got exactly the same answer. Am I right? Clear? Clear, my dear?
Yes.
Okay, now we just go back for the second question, because we have to find what should be the force of the second wire on the first wire. My dear, again, just go back to the picture. Just go back to the picture. Better I can just take the picture one more time. Okay, now we are going to calculate the second wire. So what should be the net force, my dear? Could you please tell me the answer for the second one? The force on the second wire, which is exactly equal to the force of second wire on the first wire. Am I right? Plus the force of second wire on third wire, plus the force on second wire on fourth wire, plus the force on second wire on the fifth wire. Am I right? Am I right or not?
Yes.
Yes.
Yes, Doctor.
Okay,
Right.
now we know the rule. So I just want to skip some steps because I don't want to repeat the same thing, because we know the formula mu naught I square L, because all the wires carrying the identical current. So what I'm going to do, I'm going to take the common terms mu naught I square L divided by 2 pi. Okay, what's the distance between force of second? My dear, could you please tell me what's the distance between second wire and the first wire, my dear?
Minus D.
Because you have to see in the left hand side, if you consider one wire, left hand side represent the negative, right hand side all represent the positive. So what's the distance between second wire and the first wire?
Minus D.
Minus D.
Minus D. Good. Likewise, press
Mhm.
second one. Mu naught I square L over 2 pi. What's the distance between wire second and the third?
D.
D. D.
Very good. Only D. And what should be the distance from the second wire and the fourth wire?
2D.
2D. What's the distance between second wire and the fifth wire?
3D.
3D. That's it. So better I have to write it again. So mu naught I square L over 2 pi 2D plus mu naught I square L over 2 pi 3D. Now take the common term outside. Again, I'm going to take the same common term. What are the common terms? Mu naught I square L over 2 pi D. I'm going to take it outside. So what will come inside, my dear? Tell me the answer. Minus 1.
Minus 1.
Because minus 1 over minus 1, 1 over minus 1 is nothing but minus 1. And here, plus 1,
One.
because 1 over 1. Am I right?
1, yes.
And here 1 over 2,
Over 2.
here 1 over 3. Now if you take the LCM for the bracket symbol, so what you will get, my dear? So mu naught I square L over 2 pi D, and if you take the LCM, I am going to take 6 is the LCM because common term. So if you want to get 6 here also you have 1, am I right? So you have to multiply by 6, so this becomes minus 6, am I right?
Yes.
Am I right or not? Clear?
Yes.
And
Plus-
here, if you
plus
want to
6.
get 6, here you have to get plus 6. If you want to get 6, you have to multiply by 3. So in the numerator also you have to multiply by 3. So plus 3. And if you want to get, so you have to multiply by 2. In the numerator you have to multiply by 2 plus 2. So that means plus 6 and minus 6 get cancelled. So you will get 5 over 6. So that means the second wire force mu naught. What's the value for mu naught? 4 pi multiply by 10 to the power of minus 7 and 3 square, and the length is 20 meter divided by 2 multiplied by pi, and the distance D is given as 8 centimeter multiplied by 5 over 6. Could you please tell me the answer?
3.75 multiplied by 10
3.75 multiplied by
to the power minus 4.
minus 4. Unit is Newton, and again all these 5 wires are in the
J-cap.
y-axis, so J cap. My dear, in the similar way you have to do it for the third. So that means when you consider the third wire, so I'm going to stop up to 3 wires. Okay, the rest of the fourth wire and fifth wire you have to follow the same method. I don't want to waste the time. Clear, my dear?
Doctor,
Okay, better we just yes.
what is the final answer in the previous?
You want to see
Yes, 3.7.
5 multiplied by 10 to the power of minus 4. You also gave the same, am I right? Yes. So that means
Yes,
our
yes.
answer exactly matched with our answer. So see here, we also get the same. Clear?
Yes, clear.
Okay, let's just go for one more wire, and then the rest of the 2 wires you have to do it the same way. Okay, so force on third wire. So what should be the equation? Force 3 on 1 plus force 3 on 2 plus force 3 on 4 plus force 3 on 5. So now you must know, because what we have to take, this is our reference. So whatever the things comes in the left hand side, you have to consider the negative. So what's the distance between the third wire and the first wire?
Minus 2D.
Minus 2D. What's the distance between the third wire and the second wire?
Minus
Minus
D.
D.
Minus D. What's the distance between the third wire and the fourth wire?
D.
Plus D. What's the distance between the third wire and the fifth wire?
2D.
2D.
So that means everything will be cancelled. Finally, your answer will be 0. Am I right? Because left hand side you have 1 over minus 2, 1 over minus 1. Right hand side you have 1 over 1 plus 1 over 1. So what should be your answer? No need to show, because the answer clearly shows. What's the answer?
0.
0. If you
0.
substitute the value, for sure you'll get the answer. Better if you want, I can do it, no problem. So what you will get, my dear? So better I can take the common
Yes.
terms, mu naught I square L over 2 pi d. I am going to take it outside. So what we will get here? Minus 1 over 2 minus 1 over 1. Am I right? Likewise here, plus 1 over 1. Here plus 1 over 2. So what will happen? Minus half get cancelled with plus half. Minus 1 get cancelled with plus 1. So what should be the answer? Anything multiplied by 0 is nothing but 0. That means your answer for the third wire for on the remaining wires will give the answer of 0, because it is exactly the center of the wire. So left hand side you have 2 wires, right hand side you have 2 wires. So it will cancel each other. Clear? Clear, my dear?
Here, yes.
Okay. What will be happen to the fourth wire? What's the distance? Because if you consider the fourth wire, my dear, what's the distance between first wire and the fourth wire?
3, no, minus 3D.
Minus 3D. What's the distance between the second wire and fourth wire? Minus 2D. What's the distance between wire 4 and 3? We'll get minus D. And what's the distance between fourth wire and fifth wire? Plus D. So that means here you get plus D. Here you will get minus D. Here you will get minus 2D. Here you will get minus 3D. So again, you have to follow the same method. You have to get the answer. So likewise, you have to find the answer for the fifth wire. So fifth wire, you will never get any positive value. All the things are negative. Am I right? Am I right or not? When you go for fifth
Yes.
wire, what will happen? When you go for fifth wire, what will happen, my dear?
All the distance will be in the left.
All the distance will be in the left. That
Negative.
means, yes, your answer must be negative. That means the distance between the wire 5 on 1 is nothing but 4D, minus 4D. Am I right? This one, minus 3D.
Minus 3D.
This one, minus 2D.
2D.
This one, minus D. That means your answer will comes in terms of negative value. Clear? Clear?
Yes, yes, doctor. Clear.
So in the similar, my dear, this question is one of the important question. So please, you should very, very careful. Please take a practice. Clear? Clear, my dear?
Yes, yes, doctor.
Okay.
Yes, doctor. Clear,
So
clear.
our answer is exactly the same way what we just solved. So here your answer for the fourth question and fifth question will comes in terms of negative value, because in the fourth part you have the negative answer more. In the fifth part everything is negative. So your fourth answer and the fifth answer in the sub part will get the negative answer. Clear? So we have to come for our 23rd question. So once we solve these questions, better we can just move to chapter number 30. So please read the question. And if you want to know what formula we are going to use in this question, we just go back to our theory slides. We are going to use this formula. My dear, what we studied in this slide, my dear, if you have any radius from the center to the outside of the wire, that means if your radius is greater than the radius what we are going to take outside. For example, you can see this is our wire. The blue color line is the wire. So that means the radius of the wire here is mentioned as R, and we are going to find what should be the magnetic field at a distance small r. That means here your radius, that means the distance small r is greater than capital R. So whenever you have this condition, you have to use this formula. But suppose if your radius of the wire is smaller than the point what we are going to consider, that means if any point is inside the wire, by the time what will happen? The radius. Better we can do one thing. If you want to avoid the confusion, we will do one thing. We can consider here the capital R, I think so. Am I right? We can consider the capital R as a small a. What will happen, my dear? If we consider the capital R as a small a, what should be the answer here? B, which is equal to mu
Naught
naught I
I
multiplied by
2 pi
small r
is
divided by
2
2
pi
pi
a square.
a square. So don't get confused because here both represent the r. So better we can, because the question they give the information about the capital R as a. You can just go back to your question. You can see here they clearly mention a as the radius of the wire. Am I right? Actually, this a is nothing but our capital R. So that's what I just convert everything here. So what formula, my dear? Inside the wire, your formula is B, which is equal to mu naught I multiplied by R over 2 pi a square. Outside the wire, what's the formula? Mu naught I over 2 pi r. Am I right? Am I right? So that means this is inside the wire. This is outside the wire. So now you have to read the question very carefully. The picture is given. Again, this question has 4 subdivisions. So you have to compare the value of A with R. So whether your radius, because what we studied here, my dear, if your R value is greater than, if your R value is greater than A value, you have to use this formula. Suppose if your R value is smaller than A, you have to use this formula. So please compare the value of R as well as A in this question. Once you compare, then you will get the clear answer. So let's read the question and then we will solve the questions one by one. So one of the easiest question, the only thing you must compare the value of A with R because they clearly mention. The figure shows the cross-sectional area of the cross-section across the diameter of the long cylindrical conducting wire of radius A. That means they clearly mention the radius of the wire is 2 centimeter, carrying the current of 170 amperes. How much current is it is carrying? 170 amperes. Now, what is the magnitude of the current magnetic field at a radial distance 0? So that means you have to compare A with R. So what is your radial distance, my dear? In the first question, what is the distance between the radial distance? 0. So which condition? So could you please compare your R value with the A value? Which one is greater?
A value.
So which formula you are going to use?
Bn.
This one, am I right? The first one,
Yes,
am I right or not?
First one.
So let's substitute the value. What's the formula? B, which is equal to mu naught I multiplied by R divided by 2 pi a square. My dear, your R value is 0. If you substitute 0, what will happen? Everything becomes 0. Am I right?
Yes.
Am I right?
Yes.
Okay, let's go for the second question. Let's go for the second question. Our A value is given in the question as 2 centimeter. And what should be your R value? What should be your R value? 6 millimeter. Which one is greater? Which one is smaller, my dear?
A is greater. A greater.
That means again my A value is greater than R. So which formula you are going to use here? B, which is equal to mu naught I multiplied by R divided by 2 pi a square. Am I right?
Yes.
Okay, substitute the value. The mu naught value is 4 multiplied by 10 to the power of minus 7. And the current they clearly mention as 170 ampere. 170 ampere. And the value of the R is given as 6 millimeter. So better I have to convert in terms of meter divided by 2 multiplied by pi multiplied by a square. What's the value of A, my dear? 2 centimeters. So I have to convert in terms of meter square. Could you please tell me the answer?
Uh, 5.1 multiplied by 10 to the power of minus 4.
5.1 multiplied by 10 to the power of minus
4.
4. What's the unit for the magnetic field? It's a Tesla. Am I right?
Yes.
So this will be the answer. Okay. Finally, we will confirm
Yes,
our answer. Okay. Okay. Third part. What is your C value? What is your R value, my dear?
2 centimeter, the same.
What is your A value?
At 2 millimeter.
So that means both are exactly
Yes,
the
yes,
same
yes.
value. Am I right?
Yes.
Am I right or not?
Yes.
If both are exactly same, still the wire is still the radius of the A is, R is not small. Am I right? So it's exactly on the wire. So on the wire means which formula you are going to use? Which formula you are going to use?
The first one.
Again, we are going to use
Also
the first
the
one. Why?
first
Because still our value not crossing the second case. Am I right?
in the wire, not
So
out the wire.
yes, clear. Still we have to consider the value.
Yes,
So
yes.
if your A value gets smaller than R, then only you have to go for the second formula. But what is the case for the third question? My A value is 2, my R value is 2. That means still it is exactly on the wire. Am I right? Am I right or not? Still it is
So
not going away.
yes, yes.
Clear. So we have to still use the third form, the first one again. So what is the value of A? My A value is 2 centimeter. My R value is 2 centimeter. So both are exactly the same, but it is exactly on the wire. So what I have to do? Again, I have to use the same formula divided by 2 pi A square. So what's the value? 4 multiplied by 10 to the power of minus 7 multiplied by 170 ampere multiplied by my radius 2 multiplied by 10 to the power of minus 2. Sorry, minus 2, correct? Divided by what's the value of A? 2 multiplied by pi multiplied by 2 multiplied by
So
10 to the power of minus 2 the whole square. Could you please tell me the answer, my dear?
4 pi, doctor, or 4 alone.
1.7.
Which one?
The numerator, the mu naught.
Numerator 4 multiplied by 4 pi. Sorry. Here also 4 pi. I forget.
Yes.
Okay. That means so here what's the answer? My dear, it's my kind request. Don't give my answer. Please try to cross-check your answer. Once you give your answer, then I can confirm. I can check my answer, what I gave on the slides. So please don't copy my answer. I just ask you to calculate by yourself. Tell me your answer. What's the answer?
1.7
Okay.
multiplied by 10 to the power minus 4.
Minus 4.
Yes. Just
Are you sure?
yes.
Okay. So let's we come for our fourth question. What is our fourth question? Better I can include one more page. Yeah, it's already included.
No, Doctor.
What is our
minus
fourth?
3.
That's what I'm asking you.
Yes. Sorry, Doctor.
So it's okay. Okay. Now, what is your fourth answer? My A value is 2 centimeter, but my R value is 5.9 centimeter. Which one is greater?
R.
R value. So which formula you are going to use? Second formula. So we have to compare. If you got this type of question, you have to compare the value. So for calculating the fourth answer, my A value is 2 centimeter. My R value is 5.9 centimeter. 5.9 centimeters. So which formula I am going to use? Mu naught I divided by 2 pi R. So now I have to substitute the value. 4 pi multiplied by 10 to the power of minus 7, and the current it's carrying is 170 ampere divided by 2 pi multiplied by my R value is 5.9 centimeters. So I have to convert it to meter. Could you please tell me the answer, my dear?
5.76.
5.76 multiplied by 10 to the power of
minus 4.
minus 4 Tesla. So these are all the answer. So we will just cross check our answer. The first one is 0. Second one is 5.1 10 to the power of minus 4. First one is 0. Very good. And second one is 5.1 10 to the power of minus 4. And the third one is 1.7 multiplied by 10 to the power of minus 3. So it's correct. And then fourth one, we got 5.76. That means all our 4 answers are correct. Am I right? Am I right? Clear?
Yes. Clear. Very
So
clear.
please, my dear, if you listen, my dear, if you got these type of question, please don't leave it as an empty space. Better write, my dear. It's very easy. The only thing you have to memorize the formula. The problem, the formula what we are using for chapter number 29 are very easy. It's a direct question. Only the size of the question. So for example, if you see the first question, there are many subdivisions. That's what your answer for each part will be little bit, it looks like very big in size. But the concept, once you know the concept, the rest of the things are very easy. So we just exactly use what we discussed from the class. Am I right? Is there any questions away from the class, my dear? Whatever the things we studied, exactly we are utilizing the concept here. Am I right or not? Clear?
Yes, yes. Doctor, for
Uh,
like this question, the previous one, the parallel, you will
Yes.
give me 2, 3 subdivision or what?
Yes, maybe
Or
two,
one?
3 subdivision. Each question carries 1 mark, like that we will give. Clear? But please, my dear, listen carefully. Suppose, for example, if you got this question in your final exam, for example, if you made a mistake in the first part, what will happen? Everything will be wrong. So please write the rule very carefully, and please use your calculator while you calculate the value of the force. If one parameter will be wrong, then the rest of the things, everything will be wrong. Clear? Clear, my dear?
Yes, doctor.
So please take practice. We are almost at the end of the session of chapter of physics 2. So that means all the 3 questions we already discussed. So now it's our time, because right now the time is exactly 10:50. So still we have 1 period. So I don't want to waste the time. So better we can go, because for chapter number 30 we are going to study only 2 definitions. We are not going to study that much big chapter, my dear. This chapter was very easy. Actually, the content wise, there are a little bit more information, but we already said, we discussed in our female branch with male branch that we reduce the number of problems from our Ramadan to the last chapter. So when we just reduce the number of problems, and also, it's the time was very short. So in the last chapter, we consider only 2 definitions. So we are going to study the concept of induction. So how we are going to get the EMF? What is EMF? In chapter number 27, we study the concept of EMF. What is EMF, my dear? The EMF is nothing but it's a voltage. For example, if you want to get the voltage, you need a battery. Am I right? Am I right or not?
Yes, yes, doctor.
Yes.
Without battery, is it possible to get the current?
No.
For example, you have a circuit diagram, you connected the wires in the battery, you connected some bulb or resistance something, and when you just turn on the battery, your bulb will glow because of the current flowing from the battery. Am I right? Am I right
Yes,
or not? Suppose if you don't have a battery, is it possible to get the current in the wire?
No.
No? Are you sure? Even
Maybe
if you don't
something.
have any batteries, my dear, even if you have no battery, you can get some voltage. You can get some voltage. That means if you get some voltage, means there may be some current. That is nothing but the Faraday's law. You already studied this law in your school. So without any batteries, we can get some EMF, some voltage. That means if there is any voltage, means there will be some current, because if your bulb will be glowing, means for sure based on the voltage some current will be there. Based on the current, the bulb will glow. So that concept we are going to study it in chapter 30, and I'm going to show you 2 videos. So better we can do one thing. First of all, I will just give you some idea, and after that I will turn on the 2 videos, and we are going to solve only 1 numerical question in that chapter. Clear, my dear? Clear? I'm going to explain 2 definition, and for sure this question will be in your final exam paper, because we choose only 1 problem. Am I right? Am I right or not? That means similar type of problems will be in your question paper. And
Yes,
these 2 definitions, some one theory question will be there, 1 numerical question will be there, because this chapter is already not tested in your quiz 2, midterm, and quiz 1. So that means for sure the problem what we are going to discuss in this chapter must be in the similar type of problem will be in your exam paper. So please don't lose this type of opportunity in the final exam. So better I can just give some idea, and then I will just turn the two videos, because I have two videos here. You can see here Faraday's law video and Lenz's law video we have. When you just see this animated video, you will get some idea. So before that, what I'm going to do, what I have to do, better we can start with the video. Can we start with the video? And after that, I will give the explanation. First, you just have a look.
Okay.
And after that, I will give it. Okay? Which one is good? Video
Okay.
you need first or the slides you need first?
Video.
I think the video
Okay.
first and your.
Okay. Okay, that's good. After that, I will just show you what we have in the slides.
Yes, Doctor. Good.
First of all, better I can open the slides to give the chapters details and what are the contents. So after that, I will turn on the video. That will be good. Okay, that will be the right way. Okay, so the title of the chapter is Induction and Inductance, and in this chapter we are going to study two definition. The first definition is based on the Faraday's law of induction, and the second definition is based on the Lenz law. My dear, don't get a panic about these two laws. Actually, what the scientist Lenz he did, he take the Faraday's law and he just found our small information. Apart from that, both equations are exactly the same. The formula what we are going to study from the Faraday's law, which will be exactly similar here, exactly the same. What Lenz he did later on, after the invention of the Faraday's formula, Lenz he took the formula of Faraday and he found a small information, and that's what he gave he gave his name. So that means the formula for both definition will be exactly the same, but here you will get a sign. That means that when you just study the law of Lenz, you are going to study the direction of the current. But in Faraday's law, you are going to study the magnitude of the EMF. So after that, Lenz came, he take the formula of Faraday's and he just find the direction of the current flowing through the circuit. So when you just see this, what you understand from this circuit diagram, my dear, I will just go one by one and then I will just open the video. What you understand from this picture, you have to see here Faraday's experiment. What are the things you are using, my dear? Is there any battery here? Could you please just see this picture? Is there any battery here? We have the galvanometer. Galvanometer will give the voltage information. That means here we have a coil, and this coil is like a loop-like structure, and we connected the galvanometer, which will give you the voltage information. And now we are going to take a magnet. The magnet will have two poles, north pole and south pole. So what you understand from this, if you want to get the current in this coil, what you have to do, you have to move this magnet into the loop very faster. So the informations are given clearly here. You can see we give 3 points here. So if you want to get the induced current or induced EMF, what you have to do, you have to follow these 3 points. What is given in the first point? The current appears only if there is a relative motion between the magnet and the loop. You can see here the magnet is number 2 and the loop is number 1. What is the meaning for relative motion, my dear? For example, the relative motion is nothing but if you keep one as a constant or stationary, when you just move another thing. For example, here I am going to keep the loop as a constant, as a stationary. I am going to move the magnet faster. That is nothing but the relative motion between the magnet and the loop. So when you just move the magnet with that means when you just have the relative motion between the magnet and the loop, what will happen? The current will be induced in this loop. How? Because of the magnetic field. The second thing, faster the motion, greater the current. That means if you slowly insert the magnet, you will never get any information. So what you have to do, if you want to get the current in this coil, what you have to do, you have to move the magnet very faster into the loop. Then only you can find the deflection in this meter. And the third one, if you reverse the direction of the motion or the polarity of the magnet, the current reverses. That means here, if I took North Pole inside, maybe the pointer will move left hand side. When I just reverse the polarity of the magnet, what will happen? The pointer will move to the right hand side. That means you have both deflection, right side and the left side, by changing the polarity of the magnet. That means if you follow these 3 points, you will get the EMF in this galvanometer. You will get the induced EMF, which is nothing because we did not touch anything. That's what the information is given as induction, because we did not touch anything. We just only move the magnet into the loop very faster. And the second thing, we are just consider the relative motion. Either you keep the magnet as constant, you can move the loop. Or if you want to keep the loop as constant, if you want to move the magnet, both will give the same answer. But the most important thing, there may be some relative motion. Clear? And the second important thing, you must move the magnet faster. So if you just follow this, you will get the induced EMF. So for example, in this picture, we have only one loop, but here what we have, my dear, you can see here we have 2 loops, and here we have a battery. What's the reason for battery here? We just have the connecting the battery only in the first loop, because there are 2 different laws given by Faraday's. What is the difference between the first diagram and the second diagram, my dear? What you understand from the first diagram, we have only one magnet, we have only one loop. But in the second diagram, we have 2 loops. In one of the loops, we connected the battery. In another loop, nothing. But what we are going to do, we are going to keep these 2 coils very closer to each other, and we are going to make the current flowing through this first loop. That means in the first loop, when you pass the current, what will happen? We already studied. Whenever the current carrying coil is there, surrounding the coil will be the magnetic field, because the magnetic field will be generated by the coil. And you have to make the magnetic field from the first loop to the second loop. When you just keep this coil closer to each other, what will happen? The magnetic field from the loop 1 will enter the loop of the second one. By the time some deflection will be there. Because our main concept, what we are going to find from here. What should be the deflection? So either you can use the magnet or you can use the current carrying coil. When you place the current carrying coil near to the one of the loop, what will happen? The current carrying coil will have the magnetic field, and that magnetic field will going into the loop of the second loop. What will happen? Then you can find the deflection. So when you just see the video, by the time you will get some idea. So better I can turn on the video and please enjoy, because when you just see the animated video, by the time you will get a clear idea. Can I just turn on the video, my dear? Is it clear? Clear?
Yes, sir.
Yes,
Yes,
yes.
yes.
Let's have a discussion on Faraday's law of electromagnetic induction. This is most important and basic law of electrical technology. We can say electrical technology is mainly based on this law. Operation of most basic components of electrical system like electrical motors, generators, electrical transformers, and inductors, etc. are based on Faraday's law of electromagnetic induction. This law shows the relationship between electric circuit and magnetic field. He found that when an electrical conductor is brought under the influence of a magnetic field, and if the flux linked with the conductor due to this magnetic field is changed, an EMF is induced in the conductor. In this experiment, Faraday takes a magnet and a coil and connects a galvanometer across the coil. At starting, the magnet is at rest, so there is no deflection in the galvanometer. That is, needle of galvanometer is at center or 0 position. When the magnet is moved towards the coil, the needle of galvanometer deflects in one direction. When the magnet is held stationary at that position, the needle of galvanometer returns back to 0 position. Now, when the magnet is moved away from the coil, there is some deflection in the needle, but in opposite direction. Again, when the magnet becomes stationary at that point with respect to the coil, the needle of galvanometer returns back to zero position. Similarly, if the magnet is held stationary and the coil is moved away and towards the magnet, the galvanometer shows deflection in similar manner. He also found that if these movements are made faster, the deflection of needle of the galvanometer is also more. That indicates faster the change in the magnetic field, the greater will be the induced EMF or voltage in the coil. From this experiment, Faraday concluded that whenever there is relative motion between conductor and a magnetic field, the flux linkage with the coil changes, and this change in flux induces a voltage across the coil. Michael Faraday formulated two laws on the basis of above experiments. These laws are called Faraday's laws of electromagnetic induction. Any change in the magnetic field of a coil of wire will cause an EMF to be induced in the coil. This is known as Faraday's first law of electromagnetic induction. And second law states that the magnitude of EMF induced in the coil is equal to the rate of change of flux linkages with the coil. Now let's establish an equation for Faraday's laws of electromagnetic induction. Consider a magnet approaching towards a coil. Here we consider two instants at time t1 and time t2. Flux linkage with the coil at time t1 is N into phi1 Weber, and flux linkage with the coil at time t2 is N into phi2 Weber. Hence, change in flux linkage is given by N into phi2 minus phi1. Let this change in flux linkage be phi equals phi2 minus phi1. So, the change in flux linkage would be N into phi. Now the rate of change of flux linkage would be N into phi divided by time t. Taking derivative, we will get the rate of change of flux linkage N d phi dt. But according to Faraday's law of electromagnetic induction, the rate of change of flux linkage is equal to induced EMF. So it can be written as E equals minus N d phi dt. The significance of this minus sign is due to Lenz's law. Since the induced EMF opposes the very cause of it, that is rate of change of flux with respect to time. It means change of flux with respect to time induces EMF in the coil. So induced EMF will oppose change of flux with respect to time. Hope you understand. Thank you.
Is it clear, my dear? Is it clear?
Yes, yes, doctor.
So that means here, this is called as magnitude of the EMF. So we are going to use this formula for finding the induced EMF. So here this negative sign is given by the scientist Lenz. So when you just take the magnitude, so we don't bother about this negative, but later on Lenz came and he used the formula of Faraday and he just include the sign negative to find the, because this negative indicates the direction of the current flowing through the coil. So what is this flux, my dear? The flux is nothing but how many number of field, that means the magnetic field lines entering the loop. We already studied the electric flux in chapter number 22. Do you remember that? Do you remember that electric flux?
Yes,
We
yes.
just studied the flux entering, how many number of lines entering the loop, entering the area. In chapter number 22, we studied the concept of, not chapter number 20, Gauss law. When we studied the number of field lines, the electrical field lines entering the area, we find the electric flux. Likewise here, the number of magnetic field lines entering the loop gives you the magnetic flux. So both are same exactly. Whatever the things we studied in the electricity and the magnetism are exactly similar. Clear? So here, if you want to find the magnetic flux, we have to use the symbol phi, which is exactly B multiplied by A, because here we consider the area of the loop. Clear, my dear? So we are going to use this formula for the Faraday's. So actually we have to use this E as EMF, which is like epsilon symbol, which is exactly equal to N multiplied by d phi over dt. What is this N stands for, my dear? What's the number? What's the N? N is nothing but the number of loop. For example, here how many loops we take? How many loops we take, my dear?
One loop, doctor.
Only one loop. Suppose if I take N number of loops, then you have to include the number. For example, if I have 5 loops, what I have to do? I have to take my N, which is exactly equal to 5. Clear? Clear, my dear? So N stands for the number of loops. Keep this information in your mind. If you take only one loop, then N carries the value of 1. If you take N or N which is equal to 5 to 10 loops, then you have to take the N value as 10 or 5. So the number of loops indicates the N value. So what we are going to use, we are going to use this law for Faraday's law. Clear? And we are going to solve only one question from this chapter. And I told you
We
this
should take
negative
the
exactly came. Yes, my dear?
We should take the magnitude for the
Yes, actually,
here.
for the Faraday's law, for sure, we are going to take only the magnitude. That means we are just going to get the voltage. Am I right? The magnitude of the EMF unit is nothing but the voltage. Am I right?
Yes, yes, doctor.
Clear? But if you want to know what is Lenz's law, I will just play one more video, because Faraday's, he took the same Lenz, he took the same formula from Faraday, but he found the direction of the current. So better I can just turn on the video of the Lenz's law, and please just have a look. At least you know, when you just see the animated video, you will get some information. So better I will just turn on the video of the Lenz's law, and please have a look. This is just for getting some idea.
Lenz's law helps us to find the direction of the induced current in a loop when it is placed in a magnetic field which is changing. As the magnet moves towards the solenoid, this induces current in the solenoid. The induced current creates a magnetic field. The loop produces a north pole to oppose the magnetic field of the approaching north pole of the magnet. When the magnet stops moving, there is no changing magnetic field. The current in the loop is 0. Now, when the magnet is pulled away from the solenoid, there is a changing magnetic field in the loops of the solenoid. This induces current in the loop. However, this time the loop has a south pole generated, which attracts the magnet and opposes the motion of the magnet away from the solenoid. The induced current is therefore in the opposite direction.
Doctor, how we can know the direction exactly?
My dear, actually I will just show here. If you want to find the direction, again we have to use the right hand rule. Actually, when you just see this information in the physical class, then only you can see how we have to use this right hand rule. So the direction of the current will get the info. We have to use the right hand rule for finding the direction of the current. So you can just see the diagram. 3 diagrams are given, and you can just see you have to use the direction of the fingers in the direction of the movement of the current, and the thumb indicates the direction of the current. Again, the same thing what we studied from chapter number 28. So here, every time when you study the concept of this magnetic field, and if you want to find the direction of the magnetic force, or if you want to find the direction of the current in the coil, you have to use the right hand rule. And I already explained these things in the previous chapter. Am I right? when we just start taking the classes of 28, I told you when you just studied the direction of the current, then you have to use your right hand rule. The finger indicates the direction of the magnetic field and the thumb indicates the direction of the current. So what you understand from the Lenz law, for example, if you take a loop, when you just place the magnet closing to the loop, what will happen? The magnet will have some magnetic field, and what will happen when you insert this magnet into the loop, the current will be flowing through the loop, and by the time the coil will have one more magnetic field. That information was given by Lenz there. So when you have a current, what will happen? It will also have one more magnetic field. So sometimes it may be having the same poles ripple and a different magnetic. That means the north pole and the north pole meets. By the time it will have the repulsive force. So what these are all the things we already studied in the previous chapters. So if you want to find the directions, you have to use your right hand rule. But don't bother about that. Inshallah, we are going to use only the formula here. So please, my dear, listen carefully. If you have the questions of the Faraday's law, please write the Faraday's law with a negative sign. Because I told you this negative is given by Lenz, but whatever it may be, we have to honor Faraday. Because by using the Faraday's law only, he finds the direction of the current. So the Faraday's law and the Lenz law, we have to use the same rule. Clear, my dear? Clear? Understand?
Doctor, what's the important thing in the theory here, Doctor? Can
My
you
dear,
give
here
us?
theory, just what is magnetic flux? What is magnetic flux? The number of magnetic field lines passing through the loop, which is called as magnetic flux. Clear? Which is given by the formula phi, which is equal to B dot A. This is one of the theory question. Clear? So second theory question, what is Faraday's law? We know the formula. N multiplied by, actually here you can see, what is the difference between these two, my dear? Could you please just see this? What's the difference between these two formulas?
N?
N is missing. What is N here? If you consider only one loop, N is equal to 1. So if you substitute N is equal to 1, you will get this answer. Am I right?
Ah, yes.
Suppose if I include more 3 or 4 loops, what you have to do? You have to place N which is equal to 3 in numbers. But apart from that, your Faraday's law and the Lenz law, please use this formula d phi over dt. Both, better write these things. Clear? Because we are going to solve only one question in this chapter. We are going to solve only one question. We are going to solve only one question. And that question was very easy. We are going to use this rule. We are going to use this rule. Clear, my dear? Clear?
So the doctor, at the end of the exam, I should write the N and the minus sign.
Yes, you must.
Mm.
You have to.
Mhm.
Clear? If the information about the number of coil is given, please mention N which is equal to how many loops you are going to take. Suppose if the information about the loop is not given, what is the value of N?
1.
1. So simply substitute 1. That's it. Clear?
Yes, yes.
Clear, my dear? And we are going to solve this question. So still we have time. What can I do? Can I just finish this question or can I just do this experiment, this question tomorrow? Which one you need? If I
Finish
just
it,
finish
Doctor,
this chapter
please.
is over. Huh?
Finish it, please, Doctor.
Finish
But
it, yes.
my dear,
yes, good.
my dear, listen carefully. Tomorrow we have one period. If you are absent for that period, then I will mention absent the SIS.
Yes, yes, Doctor.
What
I
can
know.
I do?
What are
Can
you
I
going
finish
to
this?
do in next chapter, Doctor?
What, my
Next class.
next week?
Next class, what you are going to do if we finish this one?
You mean tomorrow?
Yes.
Yes, yes.
Tomorrow we can just discuss something about the final exam, and then if you have any questions, you can ask, and then we will just finish our
Yeah,
class.
so it's better, Doctor, to finish it right now.
Okay, that's good. Better I can finish this chapter. It's okay. Better I can include one more slides. By that I can work out here. Okay. Read each and every word very carefully. My dear, read each and every word very carefully. Because here each and every word represents something. And here we know the formula for the Faraday. What's the formula for the Faraday, my dear? The EMF, which is equal to negative N, the rate of change of flux. What is your flux? Your flux is nothing but B multiplied by area. Actually, we have to write this like this. The integration of B dot dA, which is nothing but B dA cosine theta. If theta becomes 0, you will get the maximum magnetic flux. But generally, when you take the integration of this area, you will get B multiplied by area. So the flux should be given by the formula B multiplied by A. Clear? So you have to take this formula, you have to substitute this formula here. So what you'll get? N d of BA divided by dt. So the magnetic field is the constant term. So you have to take the magnetic field outside. So you have to integrate, you have to differentiate this area with respect to time. And you already finished calculus, am I right? So in this question, we are going to use our basic differentiation method. We are going to use the basic differentiation method. So please, my dear, actually in one question, in this question, we are going to, maybe you are going to use 3 formulas. How many formulas we are going to use? We are going to use the 3 formulas. Which formula? That formula we already studied in the previous chapters. If I ask you the question, you will get a clear information. My dear, please listen this question very carefully, because for sure one question from this chapter will be in your final theory exam paper. Because we solved only one question. In the similar type, one question will be given in your final exam paper. So please don't miss this type of question in the final theory question. Clear? Final theory exam. Okay, let's read what is given. A certain elastic conducting material is stretched into a circular loop. So you have a conducting material which have the elasticity nature. That means, what's the meaning for elasticity nature? You can expand, you can shrink. What's the meaning for elasticity? It's like a rubber band. So that rubber band is nothing but the material, that magnetic, the conducting materials, and you just have that material in the circular loop. So by that, what happened? That circular loop has the radius. What's the radius, my dear? The radius of the loop is given here as 10 centimeter. And you place that in the uniform magnetic field. You place that loop in the uniform magnetic field, and that magnetic field value is given as 0.8 Tesla. And now when released, the radius of the loop starts shrinking. That means what happened, my dear? When you just release, what happened? The radius of the loop get decreased. My dear, when it is decreasing, when there is an instantaneous rate. So that means the loop has the elastic nature. When it will be decreased, my dear, for example, initially I have 10 centimeter. When the radius got shrinking, means its radius get decreasing. That means when you just have the flux rate, by the time you will get the negative. That means the rate of change of flux will give the negative value. Why? Because they give the word shrink. What is the meaning for shrink? That means the rate of flux is given as shrinking. That means the radius. That means dr over dt. The radius of the flux get shrinking. So that value is given as 75 centimeter. So I have to convert 75 10 to the power of -2 meter per second. Clear, my dear? Clear? Clear, my dear? Why and the most important thing, you have to put negative. Why we put negative? What's the reason for putting negative here? When you just release, the radius of the loop gets decreased. Because of the word shrink. Shrink means its radius get decreased. Whenever anything is reduced, we have to use the negative sign. So that means here the radius get decreased with respect to the time. That means its speed. When you just move very faster, its radius gets shrinking, and that rate is given as 75 centimeter per second. So we have to consider in terms of meter per second, and in front of this number I put negative. Why? Because the radius gets shrink here. So that for shrinking we have to mention the negative sign. And now we have to find what should be the induced EMF. What should be the induced EMF? My dear, is there any information about the loop is given here? How many loops you are going to use in this question?
1.
Why? Because they clearly mentioned you have S circular. S circular means here N, which is exactly equal to 1 loop. So what should be the formula for the induced EMF? We just before we studied the induced EMF, which is equal to negative N, the rate of change of flux. Am I right? Am I right or not? Am I right?
Yes.
Okay. Right. What is the formula for the flux, my dear? Just before we studied, the flux is nothing but magnetic field multiplied by the area of the loop. Am I right? Am I right or not?
Yes. Right.
So take this flux, and please incorporate this flux in this formula. So by that, your formula becomes EMF, induced EMF, which is equal to negative N d of B multiplied by A divided by dt. Am I right? Am I right or not?
Yes, right.
Clear? And they clearly mentioned this is a uniform magnetic field. That means it's a constant value. Am I right? So if you have a constant, you can take it outside. Am I right or not? Because it's a uniform
Yes.
magnetic field, your field will not change. So I can take, I no need to include this constant in the differentiation, because it's meaningless. So I just take the constant term outside. So what will happen to my formula? My induced EMF, which is equal to negative N multiplied by B dA over dt. Am I right? Am I right or not?
Yes.
This is right.
What this area, my dear? What is this A? A stands for area. Am I right? Which area? What is the area of the circle?
Circle by R
What
square.
is the area of the circle?
Pi r square.
Pi r square. So what I'm going to do, I'm going to take this area, I'm going to substitute here. So what will happen to your formula? My induced EMF, which is equal to negative N multiplied by B D multiplied by pi r square divided by dt. Am I right? Am I right or not?
Yes, yes.
Am I right? Okay, what is this pi? Pi is a constant, so I take it outside again. So my formula becomes EMF, which is equal to negative N B pi d of r square divided by dt. Am I right? Am I right or not?
Yes.
My dear, if you take a partial derivative of this radius with respect to time, you already studied in calculus, what should be the answer, my dear? If you just take the differentiation of this r square, what should be the value with respect to time?
2R.
2r. Very good. So what will happen? Minus EMF, induced EMF, which is equal to NB pi. When you take, you will get 2r divided 2r multiplied by dr over dt. Am I right? Because we differentiate the radius with respect to time. You already studied the partial derivative. Am I right? Do you remember that in calculus? Have you remember what you studied in calculus?
So we know the derivation, but dr over
For
dt.
example, listen, my dear, listen carefully. X, which is equal to t square. What is dx over dt?
2t.
Because we differentiate this x with respect to t. So that means d of t square over dt. That means when you differentiate the time with respect to time, no problem, you will get 2t. Am I right? Am I right or not?
Yes.
Suppose I have x which is equal to r square. So I want to find dx over dt. What will happen, my dear? 2r dx over dt. Am I right? Am I right or not? Why we include this dx over dt here? What's the reason? What's the reason? Because there is no time parameter here. If you have the same time parameter, no problem, you will get this answer. Am I right or not?
Not the dx.
But here what we have only dx. But the parameter what we have is r square. So when you just differentiate this r with respect to t, what will happen? 2r dx over dt. The same way we have here only r square. When you just find the derivative of this r square with respect to time, first you have to find the derivative of this and then multiply by dr over dt. Clear? Clear, my dear? Clear?
Yes, sir.
Okay, now substitute the value. We have all the values. What's the number of loops? How many number of loops do you have?
1.
1. Okay. Minus is here. So minus multiplied by 1. And what is your uniform magnetic field? Your magnetic field is given as 0.8 Tesla. 0.8. Pi value is exactly pi 3.14. I can just write as it is. And multiply by 2. Multiply by what's the radius? What's the value of the radius?
10
10.
centimeters.
10 multiplied
10
by
centimeter.
10
If you convert it to meter, 2 multiplied by 10 to the power of, 2 we have to mention here. So 10 multiplied by 10 to the power of minus 2. Am I right?
Minus 2. Yes.
Yes.
Multiply by, what is your dr over dt?
Minus 75.
Minus minus 75 multiplied by 10 to the power of minus 2, which will give you the answer of the induced EMF. Tell me the answer.
Uh, 0.38.
0.38. What's the unit for the EMF?
Volt.
Volt. So let's check the answer. We got 0.377, which is exactly equal to, clear. So how many formulas we used here, my dear? Could you please tell me how many formulas we used? We not only used the Faraday's law. This is our first formula. Am I right? Am I right or not? This is the main formula we used. And in this main formula, we use the flux formula. And in this flux formula, we use the area of the circle. Am I right? Am I right or not?
Yes.
Am I right or
Yes,
not?
yes, doctor.
So
Yes,
we
yes,
just
we are
use 3 formulas in this question. So the most important thing, you have to recall what you studied in the calculus. Clear, my dear? The radius is given. When you just move its radius gets shrinking at the rate of 75 centimeter per second. So you have to convert that 75 centimeter to meter per second. So which is nothing but some minus. Why we put minus?
Minus.
Because the radius gets shrinking. Whenever the radius gets shrinking, we have to indicate the negative. Because why we put this negative? Our negative and this one more negative will get cancelled. By that you will get the positive value of the volt. Am I right?
Huh.
Am I right
Yes.
or not? Clear? Clear, my dear?
Yes, yes.
So chapter is over. We completed all the 30th chapter, alhamdulillah. So still we have some time. So please, my dear, those who have the class tomorrow, please don't be absent, my dear. And the most important thing, I would like to remind you again about your assignment. Please listen my words carefully. My dear, still some students, your assignment marks is less than 10. That means it's still less than 5 also. Because I gave 2 assignments, each assignment carries the value of 5. Am I right? So please go to your SIS, educate, and please check your assignment marks. If it is less than 10, please, my dear, come and submit your assignment one more time. So please, first of all, come and meet me. Then only I can tell you which assignment you are not submitted. After I check my list, I can give you the clear information about the number of assignment, because I gave 2 assignment. If you are absent for the first assignment, you have to submit the first assignment. So please go back to your SIS educate, check your assignment marks. If you got 5 or 4.5 something, please come and meet me immediately. My dear, the time is very short. By next week, inshallah, you have to get ready for your final theory exam. And still we have this week and next week. And after the third day, I think the extended holiday is there. And when you come after the extended holidays, then you have to come for the final theory exam. So please, my dear, the time is very short. So far, whatever the marks I have, I already entered. So no need to worry about your assignment. If you did not submit any assignment, please come to my office and please get the clear information about your assignment, and then please submit your missing assignment. Clear? Clear, my dear? Understand?
Okay, doctor.
So that's it, my dear. So alhamdulillah, we finished chapter 30. So tomorrow we have class. If you have any doubts regarding your previous chapter, if you have any doubts regarding any question, we can discuss by tomorrow and next week, because next week also we have the classes for the theory. So please don't be absent. Those who are very closer to DN, my dear, you should be very, very careful. You must attend the lab. You must attend the theory class. If you are absent, then I will put absent in the SIS. And after that, please don't come to my office, and please don't come to request to change the attendance as a present. I will not do anything regarding the attendance. If you attended, I will give you the present. If you are absent, I will give absent. So please keep this information in your mind. That's it, my dear. Inshallah, see you tomorrow, my dear. Tomorrow onwards, your final lab exam will start. So those who are having lab exam in this week, so please be on time. And if you are in my section, please be on time. I already mentioned the time, and I already displayed that information in your WhatsApp group. Am I right? Am I right or not? I hope everybody got the WhatsApp group. I think your friends already posted the attendance sheet. I make 2 groups in each section. So please be on time. If you are in the first group, you should be on time. If you are in the second group, you should be on this time what I mentioned in that. Clear? Clear?
Clear.
That's it, my dear. See you inshallah tomorrow. Assalamu
Doctor,
alaikum.
I have question.
Yes. Yes, my dear.
About Faraday's law. If I got the answer with negative sign, should I make magnitude so it will be?
My dear, listen carefully. Actually, in this question, you did not get negative. Why? Because this shrinking value will convert your negative answer in terms of positive answer. So whenever you come across this word shrink, please mention your dr over dt value as negative. This dr over dt is a negative value. If you did not mention this negative, for sure your answer of your voltage will come. Is there any value of negative voltage you have, my dear? Is it possible to get negative voltage?
No.
So please, while you substitute the value, you have to substitute the value very carefully. Clear?
Okay, thank you, Doctor.
Clear, my dear?
Yes, clear.
That's it, my dear. Thank you. See you tomorrow. Assalamu alaikum. Yes, brother.